Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have an assessment about momentum paper 2 for extended candidates only. Before we start, you can go and check. We have classwork part 1 and part 2. We have homework and you have notes. If you check notes playlist, you can find notes about momentum. Before we start, as usual, you can write down here what you know about momentum. So let's revise what are the main concepts you know about momentum and what did you know, what you want to know, and at the end you can write here what you learned and then go and check your syllabus, your specifications, CIE specifications. You can find here the main points you should know about momentum. I will not answer all the questions you have in the assessment because we have repeated questions. So if you revise classwork and homework, you can know the answers in details. But you can find the bubble sheet and the mark scheme if you join Physics Blender Telegram channel. Okay? Question 1. When a molecule rebounds from a wall, a force is exerted on the wall. What causes this force? Here we have two important points to explain. Number 1, what do we mean by change of momentum? You know that impulse F delta T, which is impulse, is equal to change of momentum. Okay, so here it's clear that your answer, what causes this force, the change of momentum of the molecule causes this force. So your answer is C. The second point I would like to clarify why we exclude change of speed, kinetic energy gained or lost. So according to one of the concepts of kinetic theory of matter, collisions take place between molecules are considered as perfectly elastic. Also between molecule and the wall of the container. What does it mean, perfectly elastic collisions? It means, number 1, the kinetic energy is conserved, and according to the principle of conservation of momentum, also the momentum will be conserved. We have here two objects, X and Y, move directly towards each other and they have the same mass. So here we consider M1 is equal to M2, so we can write them as M. Okay? Object X and object Y, when they collide, they stick together as one object. So you have to apply in all momentum problems, you have to apply the law of conservation or the principle of conservation of momentum. So we have M1 U1 plus M2 U2, momentum before collision. The total momentum before collision is equal to the total momentum after collision. M1 V1 plus M2 V2. Since here we have M1 is equal to M2 equals to M, when we substitute, so we will write here the initial velocity for the first object X. So we'll write here 5m plus the initial velocity of object Y. When you substitute here, you have to take into consideration directions, Here you are substituting velocity, which is a vector quantity. So when you substitute here 3, it's a magnitude of velocity. So when you substitute here, it's -3, and you have also mass m. Okay? When we write here, they stick together as one object. As usual, we add common masses, so it will be m plus m. Okay? Simplify. You have here 2m. You have here 2m is equal to 2mv. It's very simple to know the value of v is equal to, cancel out here, the value of v is equal to 1 meter per second. Why this question is challenging? Because when you got your answer, you have to check. So you have to exclude first C and D. So you have to check your answer. This is the magnitude of velocity. According to the value, if you have positive, it means to the right, like the original case. If you have negative, it means in opposite direction to the original case, so it will be to the left. So your correct answer here, you have to choose. Your correct answer is B, which is to the right, because your answer is positive. Question 9. Which row correctly compares the momentum and the kinetic energy of car P and car Q? Okay, let's apply here equations. Momentum of car P is equal to mass of car P times velocity of car P. Okay, so when you substitute, you have 500, you have here 1000 times 10. So your answer is 10,000 kilogram meter per second. Okay, what about momentum of car Q? It will be 500 times 20, which is 10,000 also kilogram meter per second. Okay, so they are equal. So the momentum of car A is equal to momentum of car Q. Now we have to compare kinetic energy. How to compare kinetic energy? Kinetic energy is equal to, of car P is equal to half mv squared. When you substitute, so it's half times 1000 times 10 squared. Don't compare velocities. You have to, because kinetic energy half mv squared, you have to substitute and compare your final answer. Half times 1000 times 100. So the kinetic energy for car P is equal to 50,000 joules. Right? What about the kinetic energy for car Q? It's half mv squared, half times 500 times 20 squared. So your final answer will be 100,000 joules. So when you compare, you will find the kinetic energy of car Q is greater. So the correct answer is C. They have the same momentum, but P P, it has less kinetic energy than Q. Question 13, we have an object of mass 4 kg is moving with a velocity 3 meters per second in a straight line. And actually, guys, we are dealing here with linear momentum. We are discussing linear momentum because we have angular momentum, but it's not in our syllabus. So we are applying our simple equation to calculate momentum. P is equal to mass times velocity. You have mass of the object, which is 4, and its velocity 3. Your answer is simply 12 kilogram meter per second. So this question is very simple. Question 14 is challenging. We have here a ball falls vertically to the floor and rebounds. Again, when we see expression rebounds or recoils, you have to take into consideration directions. It will be vertically upwards, okay? Rebounds vertically upwards. So if you have here a ball falls towards the ground, then it will rebound upwards, okay? What here happens? What is the change in momentum of the ball? According to our equation, we have change in momentum can be calculated mass delta V. So we have mass V final minus V initial. Okay? The speed here, when it hits the floor, the speed is 4 meters per second. When it rebounds, the speed is 3 meters per second. Okay? So when you substitute here, you have here subtraction. I will write it in different color. Final velocity is negative 3. Initial velocity is 4. Okay? Mass of the object is 0.50. Check you have consistent units. So your final answer will be 0.50 times negative 7, which is negative 3.5 kilogram meter per second. You have to exclude A and B according to the sign you have in your answer. Negative means in opposite direction. In opposite direction to the original case, which means here in our example, it's upwards. So in opposite direction means upwards. Your answer is D. This question is challenging and is very important. The last question we have here is question 15, which is very simple. Calculate the momentum of the girl. You have her mass and you have her speed. She's running at 6 meters per second. So the momentum of the girl is equal to her mass times the velocity, which is 50 kilograms times 6. So your answer is 300 kilogram meter per second. Your correct answer is B. So this question is very simple.
Subscribe for more videos. I love physics splendor. Physics Blender. I love Physics Blender.